7 Awesome Applications of Transistors in Circuits. Transistors are fundamental electronic components that play a crucial role in modern electronics. They can be used in a wide range of applications, and here are 7 awesome applications of transistors in circuits. Amplification is one of the fundamental applications of transistors in electronic circuits. It involves using transistors to increase the strength or magnitude of an electrical signal. Transistors serve as amplifiers by controlling the flow of current between two of their terminals, usually the collector and emitter for bipolar junction transistors, or the drain and source for field effect transistors. This controlled current flow allows them to boost or amplify the input signal. Here's how amplification works with transistors. Signal input: the weak or small input signal that needs amplification is applied to the transistor's base terminal, for bipolar junction transistors, or the gate terminal, for field effect transistors. This input signal can be in the form of voltage or current. Transistor action: the transistor, based on its configuration, common emitter, common collector, common base, etc., amplifies the input signal. The transistor operates in its active region, where small variations in the input signal result in much larger variations in the output signal. Signal output: the amplified signal is obtained at the transistor's output terminal, collector for bipolar junction transistors or drain for field effect transistors. This output signal is a larger, scaled-up version of the input signal. Amplification is crucial in various electronic applications, including audio amplification. In audio equipment like amplifiers, transistors amplify weak audio signals from microphones or other sources to drive speakers and produce audible sound. Radio frequency (RF) amplification: transistors are used in RF amplifiers to boost the strength of radio signals, enabling clear reception and transmission of radio waves. Instrumentation amplifiers: in scientific and measurement instruments, transistors are used to amplify and accurately measure small and precise signals from sensors and probes. Signal processing: in various electronic systems, amplification is used to condition and process signals, making them suitable for further processing and analysis. Digital electronics: transistors are used to amplify and shape digital signals, allowing for the reliable operation of digital circuits in computers, microcontrollers, and other digital devices. Overall, amplification with transistors is a fundamental building block of modern electronics, enabling the manipulation and enhancement of electrical signals for a wide range of applications. Switching is another fundamental and important application of transistors in electronic circuits. Transistors can act as electronic switches, controlling the flow of current between two of their terminals in response to a control signal. This on-off behavior is the basis for digital logic circuits and plays a critical role in a wide range of applications. There are two primary types of transistors used for switching: bipolar junction transistors, BJT, and field effect transistors, FET. Here's how transistors are used for switching. Transistor states. Off state: when the control signal is at a specific voltage or below a certain threshold, the transistor is in the off state, and no significant current flows between its terminals, collector and emitter for BJTs, or drain and source for FETs. On state: when the control signal exceeds the threshold, the transistor enters the on state, allowing current to flow freely between its terminals. Digital logic gates: by connecting transistors in specific configurations, you can create digital logic gates such as AND, OR, NOT, NAND, and NOR gates. These gates process binary inputs, 0 and 1, and produce binary outputs. Binary operations: transistors used in digital circuits can perform binary operations like addition, subtraction, multiplication, and division, forming the foundation of modern computers and microcontrollers. Applications of transistors in switching include digital electronics: transistors serve as the building blocks of digital logic circuits, enabling the creation of complex digital systems such as microprocessors, memory chips, and digital displays. Memory devices: transistors are used in various types of memory, including dynamic random access memory, DRAM, and static random access memory, SRAM, which store and retrieve digital data in computers. Microcontrollers and microprocessors, the core processing units of computers, smartphones, and embedded systems, are made up of millions of transistors used for switching and logic operations. Digital communication, transistors are used to switch and process digital signals in communication systems, enabling the encoding, decoding, and modulation of data. Control systems, transistors are found in control circuits that manage and automate various processes, from industrial automation to household appliances. Clock generation, transistors are used in oscillator circuits to generate clock signals for synchronous operation in digital systems. Switching with transistors is fundamental to modern electronics, and the ability to control current flow electronically has revolutionized the way we process and transmit information, compute, and control various systems. Voltage regulation is an important application of transistors in electronic circuits. Transistors are used in voltage regulator circuits to maintain a stable output voltage, even when the input voltage varies. This is crucial in many electronic devices and systems to ensure that sensitive components receive a constant and reliable power supply. There are two common types of voltage regulators that use transistors: linear voltage regulators and switching voltage regulators, also known as switch-mode power supplies. Linear voltage regulators use a transistor, usually a bipolar junction transistor, to regulate the output voltage. Here's how they work. Input and output. The input voltage, usually unregulated, is connected to the regulator's input terminal, and the load, the electronic device that requires a stable voltage, is connected to the regulator's output terminal. Transistor control. The transistor acts as a variable resistor, adjusting its resistance based on the difference between the desired output voltage and the actual output voltage. When the output voltage rises above the desired level, the transistor reduces the current, and when it falls below the desired level, the transistor increases the current. Stable output. This feedback loop ensures that the output voltage remains constant and independent of variations in the input voltage, load conditions, or temperature. Linear voltage regulators are widely used in applications where low noise and simplicity are more critical than energy efficiency. They are commonly found in devices like microcontrollers, sensors, and linear power supplies. Switching voltage regulators, also known as switch-mode power supplies, use transistors, typically MOSFETs, to efficiently regulate the output voltage. Here's how they work. Pulse width modulation, PWM. The input voltage is rapidly switched on and off using a PWM control circuit. When the transistor, usually an N-channel MOSFET, is on, the energy is stored in an inductor, and when it's off, the energy is transferred to the output. Filtering. The output voltage is filtered using an inductor and a capacitor to smooth the switching waveform and provide a stable DC output voltage. Efficiency. Switching regulators are more energy efficient than linear regulators because they waste less energy as heat. They are commonly used in applications where power efficiency is crucial, such as in laptops, smartphones, and power adapters. Voltage regulation with transistors is vital in ensuring that electronic devices and circuits operate reliably, especially in applications where fluctuations in the power supply can lead to malfunctions or damage. Linear and switching voltage regulators serve these purposes by maintaining a constant voltage output under varying conditions. Oscillators are electronic circuits that generate repetitive waveforms, such as sine, square, sawtooth, or triangular waves. Transistors are frequently used in oscillator circuits to produce these periodic signals. Oscillators have numerous applications in electronics, including providing clock signals for digital systems, generating carrier signals for communication, and producing reference signals for various purposes. Transistors can be used in various oscillator configurations, such as Colpitts oscillator. This is a common LC, inductor capacitor, oscillator that employs transistors, typically bipolar junction transistors, BJTs, to generate sinusoidal waveforms. It's widely used in RF, radio frequency, applications. Hartley oscillator. Similar to the Colpitts oscillator, the Hartley oscillator also uses BJTs and LC tank circuit components to create oscillations. Wien bridge oscillator. This oscillator uses transistors, often operational amplifiers with feedback networks, to generate sinusoidal waveforms. It's often used in audio frequency applications. Relaxation oscillator. Transistors, specifically uni-junction transistors, UJTs, are used in relaxation oscillators to generate square or rectangular waves. These oscillators are commonly used for timing and pulse generation. Crystal oscillator. Although crystal oscillators primarily use piezoelectric quartz crystals, they often include transistor amplifiers to boost the crystal's signal to the required amplitude. Crystal oscillators are extremely stable and are used as precise clock sources in digital circuits. Applications of oscillators with transistors include clock generators. Oscillators with transistors are essential for generating clock signals in digital systems like microprocessors, microcontrollers, and FPGAs. These clocks synchronize the operation of various components and ensure accurate data processing. Communication systems. Oscillators are used to generate carrier signals for modulating information in radio, television, and wireless communication systems. Audio equipment. Oscillators are employed in audio devices like synthesizers and signal generators to produce musical tones and test signals. Measurement and testing. Oscillators are used in test equipment to generate known reference frequencies for calibration and measurement purposes. Signal processing. In various signal processing applications, such as filter design and spectrum analysis, oscillators are used to provide input signals. Overall, oscillators with transistors play a crucial role in generating stable and controlled repetitive waveforms, which are fundamental in various electronic applications, particularly in the fields of communication, timing, and signal generation. Signal modulation is a key application of transistors in electronics, particularly in the field of communication. Modulation is the process of varying a carrier signal's properties, such as amplitude, frequency, or phase, in accordance with an information signal to transmit data efficiently over long distances. Transistors play a significant role in modulator and demodulator, modem, circuits, which are essential in various communication systems. Here's how transistors are used in signal modulation. Amplitude modulation, AM and AM. The amplitude of a high-frequency carrier wave is varied in proportion to the information signal. Bipolar junction transistors, BJTs, or field effect transistors, FETs, can be used in the modulation process. Transmitter. Transistors amplify the audio signal to be transmitted and modulate the carrier signal's amplitude. This results in an AM signal that can be broadcast over the airwaves. Receiver. At the receiving end, transistors are used in the demodulation process to extract the original information signal from the received AM signal. Frequency modulation, FM involves varying the frequency of the carrier signal in proportion to the information signal. Voltage-controlled oscillators, VCOs, with transistors are commonly used in FM modulation circuits. Transmitter. The VCO, controlled by the information signal, generates an FM signal by varying the carrier's frequency. This FM signal is then transmitted. Receiver. In the receiver, transistors are employed to demodulate the FM signal and retrieve the original information signal. Phase modulation, PMPM, alters the phase of the carrier signal based on the information signal. Voltage-controlled phase shifters, which often use transistors, are used in phase modulation. Transmitter. The phase shifter, controlled by the information signal, introduces phase variations into the carrier signal, resulting in a PM signal. Receiver. In the receiver, transistors are used to demodulate the PM signal and recover the information signal. Digital modulation. Transistors are also used in various digital modulation schemes, such as amplitude shift keying, ASK, frequency shift keying, FSK, and phase shift keying, PSK. These modulation techniques are widely used in digital communication systems and are implemented with transistors in transmitter and receiver circuits. Signal modulation with transistors is crucial in all forms of wireless communication, including AM and FM radio broadcasting, television broadcasting, cellular and satellite communication, and data transmission over the Internet. It enables the efficient and reliable transmission of information over long distances and in the presence of noise and interference. Light-emitting diodes, LEDs, are semiconductor devices that emit light when an electric current passes through them. Transistors are crucial components in LED circuits, as they are used to control and regulate the current flowing through the LED, making them versatile for various applications, including display technology, indicators, lighting, and optical communication. Here's how transistors are used in LED circuits. Current regulation. Transistors are employed to regulate the current passing through an LED. By controlling the base current, for a bipolar junction transistor, BJT, or the gate voltage, for a field effect transistor, FET, you can adjust the current flowing through the LED to achieve the desired brightness. Switching on/off, transistors can serve as electronic switches to turn an LED on and off. When the transistor is in the on state, it allows current to flow through the LED, causing it to emit light. When the transistor is in the off state, the LED remains off. Pulse width modulation, PWM. For applications where dimming or varying the LED's brightness is required, transistors are used in conjunction with PWM. By rapidly switching the LED on and off at different duty cycles, you can achieve variable brightness levels. The transistor controls the on-off duration. Applications of LEDs with transistors include display technology. LEDs are commonly used in digital displays, such as alphanumeric and dot matrix displays, to create characters, numbers, and graphics. Transistors control the LED segments, allowing for dynamic and customizable displays. Lighting. LEDs are increasingly used for general lighting in homes, offices, and outdoor environments. Transistors are used to control the brightness and color of LED lighting systems. Indicators and signaling. LEDs are widely used as indicators in various devices, such as power indicators on electronic devices, status lights on appliances, and traffic signals on roadways. Transistors enable them to turn on and off as needed. Optical communication. In optical fiber communication systems, LEDs are used as light sources to transmit data. Transistors control the current flowing through the LED to modulate the light signal with data. Specialized lighting effects. In entertainment and decorative lighting, LEDs are used for special effects such as color changing, fading, and strobing. Transistors control these effects, creating dynamic and eye-catching lighting displays. Transistors in LED circuits provide the necessary current regulation and control, enabling the efficient and precise use of LEDs in a wide range of applications, from simple indicator lights to advanced display technology and lighting systems. Transistors are widely used in sensors and detectors to convert physical phenomena, such as temperature, light, pressure, or magnetic fields, into electrical signals that can be processed and analyzed. These electronic components play a critical role in various applications, from environmental monitoring to industrial automation. Here's how transistors are used in sensors and detectors. Signal amplification. Transistors can amplify weak electrical signals generated by sensors. When a physical parameter, e.g., temperature or light intensity, causes a change in a sensor's electrical properties, resistance, capacitance, voltage, etc., transistors are used to amplify these small variations, making them more easily measurable. Signal conditioning. Transistors are used in signal conditioning circuits to modify the output signals from sensors. This may involve filtering, amplifying, or converting the signals to ensure they are in a suitable format for further processing or display. Switching and triggering. Transistors can act as switches to trigger certain actions based on sensor input. For example, a temperature sensor can be used to turn on or off a cooling system using transistors as switching devices. Voltage to frequency conversion. Some sensors generate an analog voltage output. Transistors can be used in voltage to frequency conversion circuits, where the voltage from the sensor is transformed into a frequency modulated signal for measurement or control. Applications of sensors and detectors using transistors include temperature sensors. Transistors are used in temperature sensors such as thermistors and resistance temperature detectors, RTDs, to measure temperature variations. Transistor-based signal conditioning allows for accurate temperature measurement. Light sensors. Phototransistors are used as light sensors in various applications, including automatic lighting control, light meters, and optical communication. Pressure sensors. Transistors can be employed in pressure-sensitive devices like piezoresistive sensors to measure changes in pressure and convert them into electrical signals for monitoring and control. Proximity sensors. Inductive proximity sensors use transistors to detect the presence of metallic objects and trigger actions in industrial automation and robotics. Magnetic field sensors. Hall effect sensors, which use transistors, are used to detect magnetic fields and are common in applications like position sensing and current measurement. Gas sensors. Gas sensors based on metal oxide semiconductor (MOS) technology use transistors to detect specific gases in environmental monitoring and safety systems. Motion sensors. Passive infrared (PIR) motion sensors, often used in security and lighting systems, employ transistors for signal processing and control. Sound and vibration sensors. Transistors are used in microphones and accelerometers to convert sound and vibration into electrical signals for audio recording, structural health monitoring, and more. Transistors play a crucial role in sensors and detectors, enabling the conversion, amplification, and processing of various physical parameters into electrical signals, which can then be further analyzed, displayed, or used to trigger specific actions in a wide range of applications. These are just a few examples of the many applications of transistors in electronic circuits. Transistors are incredibly versatile and form the basis of modern electronics, enabling a wide range of functionalities in various devices and systems.